Alright, in this video, it's a slight continuation of the list video from well, the last video I did over list. At the very end, I kind of pulled up this documentation page on Python.org's website, the actual website, official website for the language, and showed that there was a couple of methods that are associated with the list. Once again, I'll quickly mention methods is an object-oriented programming term. I haven't discussed object-oriented programming yet, but Python actually is an object-oriented programming language. I may talk more about that in future languages, but just for now, because I'll probably slip up and say methods, but you can just think of them as like functions that are only available to be used on lists. Anyway, that being said, with the exception of append, because I actually used that in the last video and explained it, I'm going to kind of show you the rest of these and what they do. However, I'm just going to give you really brief, simple examples. I'm of the mindset that the best way to learn a language is to get a little bit of exposure to it, some instruction from a book or another person, and kind of give you a taste. And then the best way for you to learn it and kind of come into your own is to get a taste of it and then go play with it. People that get good at programming are typically not just super geniuses that understand stuff instantly. They are people that will go and spend minutes or hours or days or however long it takes to get good at it. I mean, matter of fact, as of right now, I'm about to start my last semester of a master's program in computer science before I go into the PhD. I never coded a single line of anything when I started the program, and I just spent hours and hours playing with stuff. And by doing that, I'm able to jump into new languages and pick them up fairly quickly. So anyway, that's my little speech about hard work and all that good stuff. Anyway, let's get to it. I'm gonna skip the append because we did that last time. So if you need to know about append, then play with it or look at my last video. Next, we're going to do the second method associated with the list is called extend. So what we'll do with extend, basically it lets you take one list and tack it on to the end of another list. So we'll just make a quick variable called myList, and I'm just going to put 1, 2, 3 in there. And then I'm going to say second list is going to be another list, and I'm going to put 4, 5, 6 in there. And then what extend will let me do is I'll go ahead and print my list out before I extend it. So you can see it just have the 1, 2, and 3. And then I can say my list dot extend, and then inside the parentheses associated with the extend call, you would put second list in there because the extend method expects a list. And then I'll go ahead and print my list out again, and you'll see that my list will start off as 1, 2, 3 like you expect. After I extend it by adding the second list to it, it will actually contain 1, 2, 3, 4, 5, 6. Pretty simple and straightforward. And go ahead and save it, and then we'll run it real quick. And there you see, there's 1, 2, 3 when I called it originally, and then 1, 2, 3, 4, 5, 6, which is after I extended it by adding the second, or extending it, which means just adding the other list to it. And that's all there is to extend. Next is insert, and what insert lets you do, append actually lets you add a new thing to at the end of the list. Well, insert is the same idea, but it lets you control where you want to put that new thing in, whether it's a number or an integer or whatever. And there's two parts to it, two arguments you have to give it. The first one is where you want to stick it. In my case, I'll put an offset of 0. I want to stick it at the very beginning of the list as opposed to the end, like you do with append. And then you stick in what you actually want to be added to the list. And I'll just say, I'll make a string that says start of the list. And then you'll see that when it's ran, save it, when it's ran, you'll have 1, 2, 3, and then start of the list is put at the beginning. You can change this to different elements or different offsets, and it would put it in the appropriate spot. I'm going to change this to end of list. There's a thing I didn't talk about in the list last time. There's a function called len. What len stands for is length. When you use this built-in function len, and you use len, open parentheses, close parentheses, the argument it expects is something you want the length of. So you can do it with list, and you'll get how many things are in the list. You can also do it with strings, and it'll tell you how many characters are in the string. And you'll see more of this when we get into writing the files and reading from files in a later video. But you could actually do this. I could say length my list, And what that would do is give me the length of the entire list, which in this case would be 3. There's 3 elements in there. So then that would become a 3 because that's the length, and then end of list. So that's actually, this is actually the equivalent of doing an append. You'll see that it goes to the end there in the list. But anyway, so if you really wanted to add something to the end of the list, you could do an assert like this, but it doesn't really make sense when you can say append. But I thought I'd show that anyway. Next is remove. Remove, what you do is you do open parentheses, close parentheses, my list.remove, or whatever your list is called, and what you want to remove. Not the offset, not where it's at, but what you actually want to remove. So I'm going to remove the number 3 from here. And if I was going to use it by offset, you would notice that that would actually be the offset of 2, because you'd have to move 2 spots to get to 3. Start here, then you go 1, 2 over. But I'm actually talking about what I actually want to remove, not the offset. And then what that'll do is it will remove that item from the list. And you see the first time is the list before I've done anything. Second time is after I've done remove, and it removes the number 3 from the list. However, with this one you have to be careful. I'm going to put 56 in there because you'll notice 56 isn't in the list. What happens if the thing is not in the list is it will actually throw an error that crashes your program. See how it crashes there? So you have to be careful. You want to make sure that if you remove something from the list, you know it's actually there. But there's ways to react to that if there's an error. It's called exception handling, and I will cover that within the next few videos because it'll start being useful when we get into file input and output. Alright, next is pop. So I'm going to do list.pop, and with pop you actually pop. With pop you actually give the offset of the item you want to remove. So say I wanted to remove this number 2 from the list, I wanted to pop it off, then I would put in pop 1 because it's an offset of 1 to get to that number, or an index of 1, whatever you want to call it. I started, like, if I started an index of 0 and offset of 0, I'd start at 1. I have to move 1 over to get to that 2. So you're actually not doing the number. You're not saying what item you want to get. You're saying what the offset of the thing is. And then I'll go ahead and say just like a generic variable, popped items. We'll say popped item. There we go. Because what pop does, remove just gets rid of it completely. Pop actually removes it, but it returns it up here. It returns it back to the same line that you call pop from. That way you can save it to a variable if you want, or check it immediately. So you'll see that when I print the list here, you'll see that the item's removed, just like with the remove function. But I'll actually be able to save it to a variable, which is what this popped item's for. So I won't lose it as long as I catch it immediately. And see there, it still removes that number 2, but then I was able to save it. Whereas remove, so the big difference between that and remove is remove won't actually let you save the item. It doesn't return it. Alright, what's next? Index is next. Let me go and alter this list here real quick. I'm going to put a bunch of 3s in there. And with index, the way it works is you say, let me just do this. Whoops. I'm just going to erase it over. My list.index, and then inside the parentheses, you're going to give, you're going to put in what you're looking for, not the offset, but what you're actually looking for. Like I want to know if there's at least one number 3 in my list. I'm just going to print out the result there. And you'll see here, it prints it out, and it says at offset 2, you're going to move over 2 to get to it. At an offset of 2, or index of 2, since it starts from 0, you'll find a 3. And what this does is with the index, what that does is it finds the first case of what you're looking for, and that's all, and it stops there. So it's not going to pay attention to these ones in the back. It's only going to find the first case. Now once again, just like earlier, there's no 4 in my list that I'm checking. It will throw an error and crash the program if it's not there. It's just the way they designed it. But once again, you can we'll talk about exception handling later on, and we'll be able to kind of take care of that and have a reaction without causing the program to crash. Count does exactly what you expect. You're gonna ask it for some. You're gonna reference something that you're looking for, and it'll tell you how many of those things are in your particular list. Like I'm gonna look for the number 3, and there's 5 number 3s in that list. So when I go to print this out, it'll say, I'm sorry, that's right, there's 4, not 5. I miscounted. 1, 2, 3, 4. So it'll say 4. Boom, right there. And then next is sort. And it actually does that what's called an in-place sort, which means it just sorts the data inside the list itself. It doesn't use extra variables or anything like that to temporarily hold stuff as it sorts it. Let's make this a little bit more interesting. I'm going to say, no way, it's not already in order. I'm going to say 3, 5.2, 5, 6.13, or 12, goodbye, and then in the very front I'm going to put hello. And you'll see with Python it'll actually, we're going to find out here, if I'm not mistaken, the way it works is it'll go ahead and it'll sort the numbers. The actual numbers will wind up in the front of the list, and it'll sort them. It'll mix float and it'll mix the float and integers together. So there's 3 and 5. It'll go 3, 5, 5.2, 6.12. Let's go ahead and make it do a 5.3 here. But it'll sort these together since they're all numbers, and it'll just sort them the mixed type, and then within the strings, I think it'll sort them alphabetically, but it'll just shove them at the end of the list after the numbers. I believe that's how it happens. But anyway, I'm going to print my list before the sort, and we'll do mylist.sort. And this one doesn't take any arguments. And then we'll turn around and print the list again after it's been sorted. And you'll see this is the unsorted, and then it goes 3, 5, 5.2, 5.3, 6.12, and then goodbye and hello. Those aren't sorted alphabetically. That's weird. That's strange. I'll have to look into that and see what's up with that, because it seems like it should sort these alphabetically. But anyway, I'll figure that out later. And the final one is mylist.reverse. Or well, it's the reverse function, and then it'd be, in my case, it'd be mylist.reverse. And what it does is it reverses the order of the elements, or not reverses the order of the elements. It reverses the data in the list. It takes it'll put goodbye in the front and hello in the back, and it flips everything else appropriately. This one also is done in place, which means no extra memory is used. And just run that, and you see the stuff's flipped. Anyway, that pretty much cut. Oh wait, wow, I'm an idiot. Wow. G comes before H alphabetically. I'm a total idiot. So that is sorted. I don't know what I was thinking. One thing I do note about sorts though, when it comes to strings, and I'll leave this for you to do homework. You can look at how ANSI. If you're using Unicode, it's different. Might be a different ball game. But if you look at actual ANSI, excuse me, not ANSI, ASCII, ASCII, ASCII tables, which is the way that it's like basically the numbers that are associated with different letters. You'll notice that a capital G has a different number association than say a lowercase g. So you will notice that like well, let me just, I'll just show you with the sort real quick, because it's kind of a neat thing or something you should note. If we make these the same words, then you know what? Actually, I'll just say apple. That way they're two different words. So it appears that apple should become before hello, right? Because A comes before H. But when you actually run this code, you will see that that hello actually comes before apple, which doesn't seem to make sense because H comes after A alphabetically. So you're kind of probably thinking like, what in the crap? Well, that's because by default this sort does a case sensitive sort, and what that basically means is it actually takes into account if it's in uppercase letters or lowercase letters. The reason that would even be in consideration, because it's just a normal human looking at stuff, you ignore case. Well, there's a thing called ASCII, It's ASCII. You should look it up. There's a whole chart on it, and there's a numeric associations between letters and between each letter and symbol and so forth and so on has some number associated with it. What just so happens that all the uppercase letters have a lower number associated with them than lowercase letters. So when you do the comparison, it all breaks down to comparing numbers, the numbers associated with them. An uppercase letter is going to be less than a lowercase letter, which is why these uppercase letters, or uppercase words, are going to come first in a case insensitive sort. But to get around that, you can actually do what's called a case sensitive sort, which is basically you coerce the strings to all be lowercase or all be uppercase before you sort them, and then you get the correct answer. But anyway, if you want more information on that, make a little bit more sense, then look at the Google an ASCII chart, ASCII. It's ASCII. All right, and that's pretty much it.